October 20th, 2025. A private telescope captures something that shouldn't exist. An amateur astronomer, working from their backyard with equipment you could buy online, photographs an interstellar visitor precisely when it's supposed to be invisible, hidden behind the most powerful light source in our solar system. The image defies every rule we know about comets. And it raises one uncomfortable question. If someone with a consumer-grade telescope can see this, where are NASA's images? Let's talk about what happened on October 20th, because this is where everything changes. An ex-user by the name of Dobsonian Power posted an image that, within hours, sent shockwaves through the amateur astronomy community and beyond. This wasn't a blurry cell phone snapshot of some distant light. This was a targeted solar observation of comet 3IATLAS, captured during solar conjunction, a period when the object is positioned almost directly behind the Sun from Earth's perspective, making professional observations nearly impossible due to the overwhelming glare. Think about what that means for a second. We're talking about an interstellar object, something that originated from beyond our solar system, hurtling toward the Sun at speeds exceeding 80 kilometers per second. On October 20th, this visitor was approximately 0.5 astronomical units from the Sun, roughly half the distance between Earth and our star, and positioned in such a way that observing it required pointing instruments dangerously close to solar disk. Professional observatories avoid this. The risk of damaging sensitive equipment is too high, and the scattered light from the Sun typically drowns out any meaningful data. Yet, here's an amateur astronomer, using what appears to be a solar-filtered telescope setup, capturing a clear image of the comet's nucleus region. And the image itself? It's not what anyone expected to see. Let me describe exactly what this photograph reveals, because every detail matters here. At the center of the frame, you see a dark, distinct nucleus, the core of the comet itself. This appears as a clearly defined dark spot, suggesting a solid, substantial object rather than the diffuse, fuzzy appearance typical of active comets. Surrounding this nucleus is what Dobsonian Power describes as a cone-shaped puff or structure extending in a specific direction. Now, here's where your understanding of basic comet behavior should make your stomach drop. This cone-shaped feature appears to be oriented sunward. It's pointing toward the Sun, not away from it. If you've ever seen a comet in photographs or with your own eyes, you know the tail always points away from the Sun. Always. This isn't a suggestion or a general tendency, it's an iron law of physics. Solar wind, the constant stream of charged particles flowing outward from the Sun, pushes gas and dust away from a comet's nucleus, creating that characteristic tail stretching millions of kilometers in the anti-solar direction. Comets don't jet material toward the Sun any more than sailboats sail directly into gale-force winds. The pressure differential makes it physically nonsensical. Yet here in this amateur image captured on October 20th, we're looking at what appears to be a directed feature pointing the wrong way. Dobsonian Power notes in their post that the image shows inverted colors, a common processing technique in solar observation to enhance contrast, but emphasizes that this is otherwise unprocessed, raw data straight from the telescope. No enhancement algorithms, no AI cleanup, no stacking of multiple exposures, just what the sensor captured in that moment. Now, before you jump to conclusions, let's address the obvious skeptical response. Could this be an optical artifact? Some quirk of the imaging setup that creates the illusion of a sunward feature? Absolutely possible. Solar observation is notoriously difficult, and filtered telescopes can produce artifacts from internal reflections, diffraction patterns, or processing errors. The inverted color scheme could be hiding something, or revealing something incorrectly. Maybe what looks like a sunward jet is actually debris or gas being illuminated from an unusual angle, creating a false impression of directionality. But here's the thing that keeps pulling at the edges of that explanation: the absence of what should be there. Look at the image again, or if you're following along and haven't seen it yet, go to X and search for Dobsonian Power's October 20th post. What's missing? The coma, the tail. the massive diffuse cloud of gas and dust that every active comet displays when it gets this close to the Sun. Comet 3IATLAS is approximately 0.5 AU from the Sun on October 20th. For context, that's closer than Mercury's orbit. At that distance, solar heating should be ferociously intense. Any volatile materials on the surface, water ice, carbon dioxide ice, frozen methane, should be sublimating rapidly, creating a massive coma tens or hundreds of thousands of kilometers across. The coma should dominate the image, making the nucleus itself difficult to see directly. Instead, we're looking at a sharp, well-defined dark object with a strange localized feature and virtually no extended envelope around it. Think about photographing a streetlight on a foggy night. You don't see a crisp point of light. You see a massive glowing halo, possibly with rays streaming through the moisture in the air. That halo is far more prominent than the actual bulb at the center. Now imagine taking that same photograph and seeing a perfectly clear, focused bulb with barely any haze around it. You'd immediately know something was wrong with the atmosphere, the light source, or your understanding of what you're looking at. That's what this image represents. A comet that close to the Sun, behaving like a comet, should be impossible to photograph this cleanly without the coma overwhelming the frame. The fact that Dobsonian power captured such a distinct nucleus suggests one of several possibilities. Either the comet is strangely inactive for its distance, or its composition is unlike typical comets, or there's some kind of shielding effect preventing normal outgassing, or we're not looking at a comet in the traditional sense at all. And then there's that sunward feature. Even if we can explain away the absence of a massive coma, even if we can rationalize some unusual composition that keeps volatiles locked beneath the surface, we still have to contend with what appears to be material projecting in the wrong direction. Some observers who've examined the image closely describe it as looking like a heated shield or a protective barrier on the sunward side, as if the object is somehow deflecting or interacting with solar radiation in a non-standard way. If you find this as unsettling as I do, you're not alone. Within hours of the image posting, amateur astronomy forums erupted with analysis and debate. Some dismissed it immediately as artifact or misinterpretation. Others began pulling up catalogue data for 3IATLAS, cross-referencing the position coordinates Dobsonian power provided, confirming that yes, this image appears to be pointed at the right location in space and time. The coordinates check out. The timing aligns with the predicted trajectory. This isn't a case of someone accidentally photographing Jupiter or a background star and claiming it's the comet. This is, as far as can be determined from available information, a legitimate observation of 3IATLAS during a period when almost no one else was looking. And it shows us something we weren't prepared to see. Now, I want to be crystal clear here. One anomalous image does not prove anything extraordinary is happening. It absolutely does not confirm alien technology or any of the more sensational theories that have started circulating. What it does, and this is important, is establish a data point that demands explanation. It creates a question mark in a place where we thought we had answers. And when you start stacking question marks, when anomaly begins piling on top of anomaly, at some point you have to stop dismissing each one individually and start asking whether the pattern itself is trying to tell you something. So let's sit with this image for a moment. An amateur captures what professionals haven't or won't during the most critical observation window before perihelion. The object appears strangely inactive for its solar distance. There's a feature that seems to defy fundamental comet physics. And all of this is happening with an interstellar visitor that's already been accumulating unusual observations since early 2025, but we'll get to those in a moment. Right now, on October 21st, 2025, as you're hearing or reading this, that object is even closer to the Sun than it was when Dobsonian power took that photograph. It's approximately 8 days from perihelion, the closest approach to the Sun, scheduled for October 29th, 8 days from the moment when, if anything unusual is going to happen, if any latent behavior is going to reveal itself, we'll see it. and the professionals who should be flooding us with data, with high-resolution images, with spectroscopic analysis, and trajectory updates. They've been conspicuously quiet during this crucial window. Which brings us to the next uncomfortable question. Why is an amateur astronomer with a backyard telescope providing the most detailed visual evidence of this object during the most important observation period? That question takes us somewhere darker than simple equipment limitations or scheduling conflicts. It takes us into territory that requires us to look at not just what we're seeing in the sky, but what we're not being shown, and to consider whether that absence is accidental or intentional, raising stakes that extend far beyond unusual solar observations. Let's break down exactly what we're looking at, piece by piece, because understanding why this image is so disturbing requires understanding what should be impossible about it. I'm going to walk you through the physics that every comet obeys, and then I'm going to show you how October 20th's photograph seems to violate those rules in ways that don't have comfortable explanations. Start with the nucleus itself, that dark, well-defined core in the center of the frame. In comet imagery, especially at close solar distances, the nucleus is usually obscured by the coma, that massive cloud of gas and dust sublimating off the surface. Seeing the nucleus this clearly at 0.5 AU is like trying to see the filament inside a light bulb while it's turned on at full brightness. The surrounding glow should wash it out completely. The fact that Dobsonian Power's image shows such sharp definition of the central object tells us immediately that something about the expected outgassing isn't happening, or at least isn't happening at the scale and intensity it should be. Now, there are scenarios where a comet might appear less active than expected. If the surface has developed a dark, desiccated crust, a layer of non-volatile material left behind after previous solar encounters, it can insulate subsurface ice and reduce outgassing rates. We've seen this with short-period comets that make repeated passes through the inner solar system. But 3IATLAS is an interstellar visitor. This is its first confirmed passage through our solar system, its first encounter with our sun's intense radiation. There shouldn't be a built-up crust from previous solar heating. The surface should be relatively pristine, packed with volatiles, and responding explosively to solar heating at this distance, unless of course its composition is radically different from typical comets, which itself would be an anomaly requiring explanation, but at least a natural one, or unless something about its structure or surface properties is preventing normal sublimation. Pin that thought. Now let's talk about that cone-shaped feature, the part of the image that turns skepticism into genuine unease. Dobsonian Power describes it as pointing sunward, and multiple independent analysts who've examined the image concur with that assessment once you account for the orientation and inverted coloring. If this is an accurate representation, and we have to emphasize if, because we're dealing with one observation subject to interpretation, then we're looking at material or structure extending in the direction of solar radiation pressure. Let me explain why that breaks physics as we understand it. The sun doesn't just emit light and heat. It produces a constant stream of charged particles called the solar wind, traveling outward at speeds between 400 and 750 kilometers per second. This wind exerts pressure, radiation pressure, on any object in its path. For diffuse material like comet dust and ionized gas, this pressure is strong enough to overcome the comet's weak gravity and push everything away from the sun. That's why comet tails always point away from the solar direction, regardless of the comet's motion. The tail isn't trailing behind the comet like smoke from a train, it's being blown outward by solar wind, sometimes even ahead of the comet if the comet is moving away from the sun. For material to extend sunward, you need a force counteracting radiation pressure. In natural scenarios, that's essentially impossible for diffuse gas or dust. It would be like watching leaves fall upward during a windstorm. The only way you get something pointing toward the sun is if it's rigidly attached to the nucleus, a physical structure, not free-floating particles. And even then, you'd expect solar heating and pressure to erode and push that structure, causing it to shed material in the anti-solar direction. Some analysts have suggested what we're seeing might be a shadow effect, a region where less material is present, creating a dark cone by contrast with brighter surrounding regions. But the image doesn't show a bright surrounding coma to create that contrast. We're looking at a relatively dark field with this cone feature clearly visible as a distinct structure, not an absence of light. Others propose it could be a jet. Comets are known to produce localized jets of gas and dust from active regions on their surfaces, sometimes at odd angles depending on the nucleus's rotation and surface topography. Jets can indeed fire in directions that aren't purely radial from the solar heating, but jets produce outward-flowing material that then gets caught by solar wind and pushed into the anti-solar hemisphere. You might see a jet's origin point as a bright spot on the sunward side, but the plume it creates would still curve away from the sun. What Dobsonian power's image appears to show is not a jet being blown back, but a feature maintained in the sunward direction. Think of it like holding a balloon in a hurricane versus seeing the hurricane somehow hold a balloon toward its eye against all wind direction. Now, could this be an optical artifact? A trick of the imaging? Absolutely possible. Solar observation involves pointing instruments into intense glare, using filters that block most wavelengths to protect sensors, internal reflections in the telescope, lens flares, diffraction patterns, processing errors. All of these can create features that aren't real. Dobsonian power mentions inverted colors, which is standard practice in solar imaging to enhance contrast, but that inversion could potentially mislead interpretation of what's actually there. Except here's the problem with dismissing it as pure artifact. The feature appears to have structure. It's not a random lens flare or symmetrical diffraction spike. It has a specific geometry and orientation relative to the nucleus and the solar direction. Artifacts tend to be either symmetrical, repetitive, or obviously out of place when you understand the optics involved. This cone-shaped structure has a logic to it, a directionality that seems intentional or at least non-random. And then we come back to the missing coma. Let's really sit with that for a moment, because it's arguably more important than the sunward feature. At 0.5 astronomical units, about 75 million kilometers from the sun, a typical comet should be producing a coma hundreds of thousands of kilometers across. For reference, Comet Neowise in 2020, when it was at a similar distance, had a coma visible to the naked eye and a tail stretching millions of kilometers. Halley's comet, at comparable solar distances, displayed massive comas captured by spacecraft in exquisite detail. 3IATLAS, on October 20th, shows almost nothing. A dark nucleus, a localized feature, and an otherwise clean field. This isn't a comet in quiet mode. This is a comet that appears to be fundamentally inactive in a region of space where it should be screaming with activity. Some have speculated that perhaps 3IATLAS is a Manx comet, a rare class of nearly tailless comets that have either lost their volatiles or never had significant amounts to begin with. These objects look like comets, but behave more like asteroids. The problem: spectroscopic observations earlier in 2025, when 3IATLAS was farther from the Sun, detected clear signs of outgassing carbon dioxide, water vapor, cyanogen compounds. This object was active. It was behaving like a comet. So what changed between then and now? This is where pattern recognition should start firing in your brain. An object that was outgassing at greater distances where solar heating is weaker suddenly appears inactive at closer distances where heating is stronger. That's backwards. Comets become more active as they approach the sun, not less. It's like watching water start to boil, then go perfectly still as you turn up the heat. One hypothesis, and this is where things get uncomfortable, is that something about the object's surface or composition changes behavior under extreme solar proximity. Maybe there's a phase transition, a chemical or physical process that essentially seals the surface when temperatures cross a certain threshold. We don't have natural examples of this in solar system science, but that doesn't mean it's impossible. It just means it would be new physics or chemistry, which itself is significant. Another hypothesis, whispered more than stated outright in scientific discussions, is that we're not looking at an object governed purely by passive thermodynamics. What if there's some process, natural or otherwise, actively controlling how this object responds to solar radiation? What if the lack of a coma isn't failure to outgas, but prevention of outgassing? Think about that for a second. Imagine an object designed to survive close solar passes. How would you engineer it? You'd want to minimize material loss, prevent erosion, maintain structural integrity under intense heating. You'd essentially want it to not behave like a comet, even if it's coated in volatile materials. You'd want exactly what we're seeing, a solid, well-defined core with minimal outgassing and possibly some kind of shielding effect on the sunward side. Now, I'm not saying that's what this is. I'm saying that when you try to explain the image using natural comet physics, you run into problems. And when those problems accumulate, low activity at high heating, sunward features that defy pressure laws, spectroscopic oddities we'll discuss shortly, you reach a point where either our understanding of comets is incomplete in fundamental ways, or we're not looking at a comet in the sense we've always understood them. Dobsonian Power's image doesn't give us answers. It gives us a puzzle where the pieces don't fit the box we've been trying to put them in. And when you combine this visual anomaly with the other observations astronomers have logged over the past several months, observations from professional instruments like Keck Observatory and Hubble Space Telescope that detected their own set of impossible features, the puzzle stops looking like a comet that's misbehaving and starts looking like something we've never had to categorize before. Which brings us to the next question. If this image is so significant, if it's capturing behavior during the most critical observation window before perihelion, then where are the professionals? Where are NASA's images, ASA's data releases, the observatories with million-dollar budgets and instruments designed exactly for this kind of work? Why is the clearest visual evidence coming from someone's backyard? That silence, that absence, might be more telling than anything visible in the photograph itself, pointing us toward possibilities that are harder to accept but increasingly difficult to ignore as the hours count down to October 29th. October 21st, 2025. We're now approximately 7 days from perihelion, the moment when 3IATLAS reaches its closest point to the Sun on October 29th. This is the most scientifically valuable observation period for any comet, the time when solar heating peaks, when outgassing behavior becomes most pronounced, when trajectory perturbations can be measured with precision, when spectroscopic signatures reveal compositional details impossible to detect at greater distances. For an interstellar object making its first known pass through our inner solar system, this window is irreplaceable. Miss it, and we're waiting for the next interstellar visitor, which could be years or decades away. So let me ask you directly, where are the images from NASA? Where's the data from ESA? From ground-based observatories with dedicated solar observation programs? From the space telescopes specifically designed to study objects in close solar proximity? Where are the press releases, the science briefings, the preprint papers flooding ArcSiv with preliminary results from this once-in-a-generation opportunity? The silence is deafening. Now, before we dive into speculation, let's address the obvious technical limitation: solar conjunction. On October 20th, through approximately October 23rd, 3IATLAS is positioned in a region of sky very close to the Sun from Earth's perspective, what astronomers call solar conjunction. This is genuinely one of the most challenging observation geometries possible. Pointing a telescope at an object near the Sun risks damage from scattered light and direct solar glare. Most observatories, especially those with sensitive infrared detectors or unfiltered optical systems, simply cannot safely observe in this region. That's a legitimate constraint. Solar conjunction is why we lose contact with Mars rovers for weeks at a time when Mars passes behind the Sun, why certain spacecraft missions go silent during these periods. It's not a cover-up. It's physics and engineering safety. But here's what doesn't add up. Amateurs are observing it. Dobsonian Power's October 20th image proves that with appropriate solar filters and careful technique, observation is possible. If a single person with consumer-grade equipment can capture a usable image, why hasn't NASA released anything from Solar Dynamics Observatory? a space telescope literally designed to stare at the sun 24/7. Why hasn't the Daniel K. Inouye Solar Telescope in Hawaii, the most powerful solar observatory on Earth, published observations showing the comet's passage? These instruments observe objects transiting the sun routinely. Comets occasionally pass through SDO's field of view, and the resulting images are spectacular and scientifically valuable. 3IATLAS is close enough to the solar disk during this period that instruments designed for solar observation should be able to capture it, especially in wavelengths where the comet's thermal emission or reflected light would stand out against solar features. Yet we've seen nothing. No images, no preliminary data, no acknowledgement that observations are even being attempted. This is where circulating rumors need careful examination. In the days leading up to October 20th, some online communities began reporting that certain observatories had been taken offline or had ceased public data releases. Specifically, claims emerged that NASA's Solar Dynamics Observatory stopped updating its publicly available imagery around October 13, 2025, a full week before the amateur photo appeared. I want to be extremely clear about this. I have not independently verified that SDO's data stream was interrupted. These reports remain anecdotal, circulating primarily on social media platforms and forums without official confirmation from NASA. It's entirely possible that data releases continued normally, that any perceived gap was routine maintenance or a mundane technical issue, or that observers misinterpreted the timing of public updates. However, the perception of silence, deserved or not, has fueled suspicions in a community already primed to question institutional transparency. When you combine a lack of visible professional observation with a stunning amateur image showing anomalous features, the absence of official data starts to feel less like coincidence and more like avoidance. Why might professional observatories be quiet during this period, assuming the silence is real and not just misperceived? Let's consider charitable explanations first. 1. Observation is genuinely difficult, and teams are prioritizing data collection over public communication. Scientists might be gathering as much raw data as possible before perihelion, planning to release analysis only after they've had time to properly interpret what they're seeing. Science doesn't happen in real time. It requires careful analysis, peer review, validation. Expecting immediate public releases during active observation campaigns might be unrealistic. 2. Observing 3IATLAS during conjunction might require specialized techniques or instruments not readily available, and the few facilities capable of doing it are running long integration times, meaning images won't be available for days or weeks while data processing completes. Space telescope observations, in particular, can have significant delays between data collection and public release. 3. And this is crucial. Professional astronomers might have observed 3IATLAS during this period and found nothing remarkable. The object might look perfectly ordinary through their instruments: standard comet outgassing, expected thermal signature, trajectory on prediction. Dobsonian Power's image might be showing an artifact or misinterpretation that higher quality professional data would easily debunk. If that's the case, there's no urgent need to release images, because there's no story to tell. But then, why not release those debunking images? Why not publish a quick statement or dataset showing, "We've observed 3IATLAS on October X with Y instrument, and it appears consistent with cometary behavior." That would instantly calm speculation and provide the scientific community with valuable comparison data against which to judge amateur observations. The absence of even that minimal communication is where doubt creeps in. Now, let's consider less charitable explanations, the ones that venture into territory many scientists would immediately dismiss, but that a growing number of observers find increasingly plausible given the pattern of anomalies surrounding 3IATLAS. What if professional observatories have imaged the object and seen something they don't know how to explain? What if the data shows features so unusual that releasing it without thorough analysis would trigger public panic or rampant speculation? Speculation that might be difficult to contain or correct once unleashed. Think about the institutional incentives at play. NASA, ESA, and major observatories are publicly funded institutions with reputations to maintain and scientific credibility to protect. Releasing ambiguous data, images that could be interpreted as showing anomalous structures, for instance, before having a solid natural explanation, risks igniting conspiracy theories, diverting public attention into unproductive speculation, and potentially damaging institutional trust if the final explanation makes the agency look incompetent or reactive. From a risk management perspective, if you've captured images of 3IATLAS that show anything unusual, the safest move is to hold those images until you've exhausted every conventional explanation. You bring in your best comet specialists, your imaging experts, your optical physicists. You run simulations, check for artifacts, analyze alternative interpretations. Only when you're confident you have the correct explanation, or at least a defensible one, do you release the data. And if that process takes days or weeks, so be it. Better to be slow and right than fast and inflammatory. The problem with this approach, from a public trust standpoint, is that silence creates a vacuum, and that vacuum gets filled with speculation, often wilder than anything the actual data would support. Amateurs like Dobsonian power step into that vacuum, and their observations, free from institutional caution, become the narrative. If professional astronomers are sitting on data that contextualizes or contradicts amateur findings, every day of silence hands credibility to alternative explanations, some of which veer into territory institutions would desperately like to avoid. And then there's the possibility that some would call conspiratorial, but that certain statements from prominent figures like Avi Loeb have lent a veneer of seriousness to what if observations are being suppressed, not to avoid scientific embarrassment, but because someone, government agencies, defense departments has flagged 3IATLAS as a potential security matter. Avi Loeb, professor of astrophysics at Harvard and former chair of the Harvard Astronomy Department, has been publicly calling for increased observation of 3IATLAS since mid-2025, specifically advocating for high-resolution imaging and spectroscopy during close solar approach. In multiple interviews and articles, Loeb has stated he believes there's a significant probability, he's estimated between 30 and 40%, that 3IATLAS might be of artificial origin. He's called for NASA to prioritize observations, and for international bodies like the United Nations to prepare contingency frameworks for potential contact or close approach scenarios. Loeb is not a fringe figure. His credentials are impeccable, his scientific output substantial. When someone of his stature publicly raises the possibility of artificial origins and calls for institutional response, and those institutions remain publicly silent, the contrast is stark. Either Loeb is being irresponsibly speculative, something his peers might argue, but which seems inconsistent with his long career, or his concerns are being quietly taken seriously in ways the public isn't being told about. If government or military entities have any reason, any data, any intelligence assessment, suggesting 3IATLAS warrants classified attention, observation data from publicly funded instruments could be restricted under national security protocols. This wouldn't be unprecedented. There are established processes for classifying astronomical observations if they intersect with security concerns, such as observations of military satellites or detection of potential asteroid impacts before public warning systems are ready. Would an interstellar object qualify for that kind of classification under normal circumstances? Absolutely not. Space science is inherently international and collaborative, and comets don't threaten national security. But if that object shows any indication of artificial origin, if there's even a whisper of possibility that it represents technology or intelligence, the calculus changes instantly. The first confirmed detection of extraterrestrial technology would be the most significant event in human history, and the strategic, political, and societal implications would be staggering. Every government with space observation capability would want to know what it is before public disclosure, and controlling the narrative would become a matter of existential importance. I'm not saying that's what's happening. I'm saying that the absence of professional imagery during this critical window is consistent with multiple explanations, some mundane and some far less comfortable. And when you place that absence alongside the image that did emerge from an amateur, showing features that defy easy explanation, the silence stops feeling like bureaucratic delay and starts feeling like evasion. We're 7 days out from perihelion as of October 21st. 7 days until 3IATLAS reaches its minimum solar distance and either behaves exactly as a comet should, breaking up, increasing outgassing, producing massive coma and tail, or does something else, something we're not prepared for. If professional observatories have been watching, if they have data, then October 29th will be the moment when staying silent becomes untenable. Either they release observations showing ordinary comet behavior, putting all speculation to rest, or they continue to withhold data, which in itself would be an answer of sorts, just not a comforting one. And then we have to ask what comes after perihelion, when 3IATLAS emerges from solar conjunction and becomes easier to observe again, when space missions like ESA's JUICE spacecraft and NASA's Juno mission have scheduled flybys to capture close-range data. Will those images align with what Dobsonian power photographed, or will they reveal something the professionals have been quietly tracking all along? The silence is not just an absence of information, it's a presence of doubt, a growing sense that something about this object has made institutions unusually cautious, and that the amateur community is inadvertently uncovering pieces of a puzzle that someone, somewhere, might prefer stayed hidden just a little bit longer, building tension toward a reveal that could reshape every assumption we hold about our place in the cosmos and what might be visiting us right now. Let's talk about what makes 3IATLAS genuinely unique, because the October 20th image from Dobsonian power isn't happening in isolation. It's one piece of a mosaic that's been forming for months, and when you step back and look at the full picture, each individual oddity might have a natural explanation, but the combination, the pattern, starts to feel like something other than coincidence. Avi Loeb has compiled what he calls a list of anomalies associated with 3IATLAS, numbering between 7 and 9 distinct observations that deviate from expected comet behavior or composition. Let me walk you through the most significant ones, because understanding why each matters individually will help you grasp why their accumulation is so unsettling. First, the composition. On August 24th, 2025, the Keck Observatory in Hawaii conducted spectroscopic observations of 3IATLAS. Spectroscopy is how we determine what something is made of by analyzing the light it emits or reflects. Different elements and molecules absorb and emit light at specific wavelengths, creating a unique fingerprint. When you analyze a comet's spectrum, you typically see signatures of water vapor, carbon monoxide, carbon dioxide, cyanogen compounds, and various dust grains. These are the building blocks of comets, the primordial material left over from solar system formation, or in this case from another star system's formation. Keck's observations detected something unexpected, an unusually high ratio of carbon dioxide to other volatiles, significantly above what's typical for solar system comets. Now, interstellar objects might have different compositional ratios depending on the chemistry of their origin system. Different stars have different elemental abundances, and those differences would show up in the planets and comets that form around them. So finding unusual ratios in an interstellar visitor isn't necessarily alarming by itself. It's interesting, notable, but explainable. Except then came the nickel detection. Keck's spectrum showed clear absorption features consistent with nickel, a metal without corresponding features for iron. That's strange. In natural astrophysical settings, nickel and iron are almost always found together because they're both products of stellar nucleosynthesis and are chemically similar, often forming alloys. Finding nickel without iron is like finding smoke without fire, not impossible, but requiring specific conditions that aren't obvious. One explanation, maybe the surface of 3IATLAS is enriched in nickel-rich minerals due to some unusual formation process or differentiation within its parent body. Certain types of asteroids show metal-rich surfaces where lighter materials have been stripped away by collisions. But 3IATLAS was classified as a comet based on its orbit and activity, not as a metallic asteroid. The presence of significant nickel without iron, especially in an object also showing outgassing, doesn't fit neatly into standard categories. And here's where minds start to wander into uncomfortable territory. Industrial alloys sometimes isolate or enrich specific metals for particular properties. Pure nickel or nickel-rich alloys have high corrosion resistance, excellent thermal stability, and are used in applications requiring durability under extreme conditions like, say, spaceflight or high-temperature environments. I'm not saying that's what we're detecting. I'm saying the observation pattern, exotic chemistry, metal signatures that don't follow natural abundance patterns, is the kind of thing that would make you pause if you were analyzing a sample in a lab and trying to determine whether it was natural ore or refined material. Now combine that with the carbon dioxide ratio. High CO5 relative to water and other volatiles could suggest a comet that formed in a particularly cold or carbon-rich environment, perfectly natural, or it could suggest an object where water has been preferentially depleted, either through previous solar heating that boiled off water while retaining higher sublimation point CO5, or through some process that removed water from the surface. Again, not impossible naturally, but adding another layer of this doesn't fit the standard model. Next anomaly, the anti-tail observed by the Hubble Space Telescope in July 2025. Comets occasionally display what's called an anti-tail, a narrow spike-like feature that appears to point toward the Sun opposite the main dust tail. This is actually a well-understood optical illusion caused by viewing geometry. When Earth crosses the comet's orbital plane, we see the dust trail edge on, creating the appearance of a sunward spike, even though the dust is actually spread along the comet's orbit in the anti-solar direction. So Hubble observing an anti-tail on 3IATLAS is not by itself anomalous. What is anomalous is its persistence and the timing. Anti-tails are usually brief, lasting only a few days as Earth crosses the orbital plane. They're geometry effects, not sustained features. Yet reports from observers tracking 3IATLAS suggested the anti-tail remained visible for longer than the crossing geometry would predict, and some descriptions noted it had unusual structure, more collimated, more narrow than typical anti-tails, which tend to be diffuse and broad. If the anti-tail is somehow maintained beyond the expected viewing geometry, that implies either sustained directional dust emission along the comet's orbit, possible, but requiring very specific outgassing behavior, or something else creating a narrow, persistent feature that mimics an anti-tail. Some have speculated it could be a physical tether or structure, though that's venturing far into speculation without evidence. Then there's the outgassing behavior we've already touched on, active at greater solar distances, strangely quiescent at closer distances. Earlier observations in 2025, when 3IATLAS was farther out, detected clear signs of a coma and spectroscopic signatures of sublimation, water, CO, cyanogen. As it's approached the Sun, visual observations, including the October 20th image, show a marked decrease in visible coma. That's the opposite of what should happen. It's like watching ice cubes in a glass start melting when you take them out of the freezer, then stop melting as you move the glass closer to a heater. There are natural mechanisms that could cause this. If the surface develops a crust of refractory material, dust and organics left behind as volatiles sublimate, it can insulate the interior and reduce further outgassing. But that process usually happens over multiple orbits as the comet repeatedly passes the Sun, building up the crust incrementally. 3IATLAS is on its first known pass. How does it already have an insulating crust? Another possibility. The comet's rotation could be exposing different surface regions to the Sun at different times, and we happen to observe it during a period when less active regions were sunward facing. Comets have irregular shapes and non-uniform surfaces. Some areas outgas vigorously, others are inactive. Rotation periods can be hours to days, so it's plausible we caught an unlucky observation window, but that would require precise coincidence of rotation phase, observation timing, and surface heterogeneity to explain the observed activity decline. Or, and this is the hypothesis Avi Loeb and others have gently raised, there's some active process controlling outgassing, not passive thermodynamics, but something regulating how and when material is released. How would that work naturally? It's unclear. How would it work artificially? That's an easier question to answer. You'd design venting systems that minimize material loss except when needed for trajectory correction or waste disposal, preventing erosion and extending operational lifetime. Next anomaly: trajectory and velocity. Interstellar objects enter the solar system on hyperbolic orbits. They're moving fast enough to escape the sun's gravity, which is how we know they came from interstellar space rather than being bound solar system members. 3IATLAS's orbit is hyperbolic with an eccentricity well above 1, confirming interstellar origin, but its velocity, while high, is not extraordinarily so. It's fast enough to be unbound, but not moving at a significant fraction of light speed or showing the extreme velocities you might expect from an object ejected violently from another system. What's curious is the precision of its trajectory. 3IATLAS passed relatively close to Earth earlier in 2025 and is now executing a close solar flyby on October 29th. Neither of these encounters is unusual by itself. Space is big, but trajectories can bring objects near multiple planets through gravitational dynamics. What draws attention is the efficiency of the path, a trajectory that allows close observation opportunities from Earth-based instruments, a perihelion distance that provides intense solar interaction without destroying the object, and a departure path that will bring it past Jupiter's orbit, where flybys from missions like Juno are scheduled in 2026. If you were designing a reconnaissance path through a planetary system, you'd want exactly that: close approaches to the central star and major planets, maximizing data collection while minimizing risk. Is 3IATLAS's trajectory optimized for observation? That's reading intent into orbital mechanics, which is dangerous. Trajectories are determined by velocities and gravity, not purpose. But the coincidence is noted. Then there's the size and albedo, how bright the object is relative to its size. Early estimates of 3IATLAS's nucleus size based on its brightness suggested an object roughly a few kilometers across, typical for a comet nucleus. But brightness depends on both size and reflectivity, albedo. If 3IATLAS has an unusually high or low albedo, the size estimate changes. Some photometric analysis suggested the albedo might be lower than typical comets, which would make the actual size larger than initial estimates. A darker, larger object would have more surface area and mass, potentially explaining some of the thermal behavior: more thermal inertia, slower response to solar heating, less volatile content per unit surface area. But low albedo also means something about the surface is absorbing rather than reflecting light, which could indicate a coating of dark organic material common in comets or something else. Loeb has noted that a low albedo, larger object with low outgassing resembles a defunct spacecraft more than an active comet, dark heat shielding, minimal venting, structurally intact. That's speculation, but it's grounded in the observation that the object is not behaving like a standard-issue comet. Now let's stack these. Unusual composition with industrial metals, anti-tail with anomalous persistence, outgassing that decreases as solar heating increases, trajectory that coincidentally maximizes observation opportunities, size and albedo, suggesting a large, dark, low-activity object. And now, on October 20th, an image showing a sharp nucleus with minimal coma and a potential sunward feature during peak solar proximity. Individually, each has potential natural explanations. Maybe the composition reflects an exotic formation environment. Maybe the anti-tail is a geometry fluke. Maybe outgassing variability is due to rotation and surface heterogeneity. Maybe the trajectory is coincidence. Maybe the albedo is standard comet organics. Maybe the October 20th image is an artifact. But here's the problem. The probability of all of these anomalies co-occurring in a single object, when each requires specific conditions to explain naturally, starts to shrink. It's the classic extraordinary claims require extraordinary evidence dilemma inverted. You're not making an extraordinary claim, you're just listing observations, but the observations collectively are becoming extraordinary through their accumulation. Avi Loeb describes this as passing a threshold. When you have one anomaly, you investigate and usually find a conventional explanation. When you have two, you note the coincidence, but proceed with natural hypotheses. 3, 4, 5 anomalies, and you're starting to stretch conventional explanations. By the time you hit 7, 8, 9 distinct oddities, all in the same object, you have to seriously consider whether the simplest explanation, the one requiring the fewest additional assumptions, is that we're not dealing with a standard natural object. Loeb has placed 3IATLAS at a 6 on his Loeb scale, a metric he developed to quantify how anomalous an object is based on the number and significance of deviations from expected behavior. A 6 indicates substantial anomalies that warrant serious investigation and consideration of non-standard hypotheses, including artificial origin. He's estimated the probability of artificial origin between 30 and 40%, not a majority, but far from negligible. That's not saying this is definitely aliens. It's saying there's a significant enough chance that we should treat this as a priority scientific and potentially security matter. And that brings us to the hypothesis that ties these anomalies together, the one that most scientists would prefer not to speak aloud, but that's circulating in the background of every conversation about 3IATLAS. What if this object is performing an Oumuamua maneuver? An Oumuamua maneuver is a spaceflight technique where you fire engines at the point of closest approach to a massive body like the Sun to maximize the change in velocity. Because kinetic energy scales with the square of velocity, burning fuel when you're already moving fast produces a much larger delta V than burning the same amount of fuel when you're moving slowly. It's a highly efficient way to alter trajectory or boost speed, and it's a standard tool in mission planning for interplanetary spacecraft. If 3IATLAS were to fire engines or deploy some propulsion mechanism at perihelion on October 29th, it would be the optimal moment to do so. Close solar proximity would mask observations, thermal signatures would be confused with solar heating, and any trajectory change would be magnified by the Oumuamua effect. It would be, in short, the perfect place and time to reveal artificial capability if that's what this is. We're 8 days away from finding out whether that speculation has any basis in reality, or whether 3IATLAS will pass perihelion as a perfectly ordinary, if unusually odd, comet, leaving behind a trail of overinterpretation and conspiracy theories that will serve as cautionary tales for future interstellar object observations, or whether October 29th becomes the date humanity's understanding of its cosmic solitude fundamentally changes. Now let's talk about what happened after Dobsonian Power's image went live on October 20th, because the story doesn't end with the raw photograph. Within hours, the image had been downloaded, shared, and critically enhanced by independent analysts using various image processing techniques. And some of those enhanced versions show features that are either deeply troubling or spectacular examples of how digital processing can create illusions depending on your interpretation and trust in the methods used. An ex-user by the handle Julio 40975, among others, posted processed versions of the October 20th image. These enhancements typically involve adjusting contrast, brightness curves, applying unsharp masks to emphasize edges, and sometimes using AI-driven upscaling or denoising algorithms to extract detail from low-signal regions. The goal, ostensibly, is to reveal structure hidden in the original data, details present but not visually apparent due to noise, dynamic range limitations, or the raw image's processing state. What Julio 40975's enhancement appears to show, and what has sent certain corners of the internet into overdrive, is a disc-shaped structure around the nucleus, not a diffuse coma, but a distinct geometric form, circular or elliptical with relatively sharp boundaries, surrounding or attached to the dark central nucleus. Some versions of the enhancement show what looks like symmetry, as if the object has a deliberate shape rather than the chaotic, irregular structure of a natural comet nucleus. Let's be extremely careful here. Enhancements can reveal real structure, but they can also introduce artifacts, false details created by the processing algorithm rather than present in the original data. AI-driven enhancement tools, in particular, are notorious for hallucinating features that look plausible but are entirely invented by the neural network based on patterns learned during training. If you've seen AI upscaling of old photos, you know it can produce startlingly clear results, but sometimes those results include details that weren't there, faces with features filled in incorrectly, textures that match what the AI thinks should be there rather than what actually is. So when we see a processed image showing a disc-shaped structure, the first question has to be, is this revealing hidden detail in Dobsonian Power's original data? Or is this the image processing algorithm imposing structure onto noise and ambiguity? Without access to the raw FITS file, the uncompressed, full-resolution data straight from the telescope's sensor, it's nearly impossible to definitively answer that question. What we're seeing on social media are compressed JPEGs or PNGs, images that have already lost information through compression and format conversion. Enhancing a JPEG is fundamentally different from enhancing raw sensor data. You're amplifying compression artifacts, interpolating missing information, and working with a degraded starting point. Any structure revealed in such enhancements should be treated with extreme skepticism unless corroborated by independent observations. That said, multiple independent analysts have processed the image using different techniques and reported seeing similar structures. When different methods applied by different people converge on similar results, that adds some weight to the idea that there might be something there, though it could also mean they're all amplifying the same artifacts in similar ways. What does this alleged disk structure look like, and why does it matter? Descriptions vary, but the common thread is that the nucleus appears to have an extended, flatter geometry, more like a disk or a oblate spheroid than the irregular, potato-shaped morphology typical of comet nuclei. Some enhancements suggest a central dark core with a surrounding ring or halo, distinct from a coma because it has defined edges and apparent solidity, rather than the diffuse, fading to background appearance of gas and dust. If you're thinking that sounds like a spacecraft with a central body and surrounding superstructure, radiators, shields, sensors, engines mounted on a chassis, you're not alone. That's exactly the comparison people are making. It's why terms like mothership and craft have started appearing in discussions, why some are comparing it to science fiction depictions of interstellar probes or ships. But here's the thing, flattened or oblate structures aren't impossible in nature. Many comet nuclei are elongated or irregular due to how they formed, through accretion of smaller particles, through collisions, through tidal forces during close encounters. If 3IATLAS is a contact binary, two smaller objects gently fused together, it could have a dumbbell or elongated shape that, when viewed edge-on, might appear disc-like. Perspective matters enormously in interpreting shape from 2D images, and even if there is a genuinely disc-shaped structure, that doesn't automatically mean artificial. Some asteroids and comets have been observed to have flattened profiles, possibly due to rapid rotation creating an equatorial bulge, or due to layering of materials during formation. It's unusual, but not impossible. So why is this causing such a stir? Because when you combine the disk shape with everything else, the lack of coma, the sunward feature, the compositional anomalies, the trajectory, it's starting to look less like an accumulation of unrelated oddities and more like a coherent picture of something structured, engineered, intentional. And that picture is profoundly uncomfortable for anyone who prefers explanations to stay within natural bounds. Then there are the other viral pieces of footage and imagery circulating online. Some users have posted videos claiming to show 3IATLAS in motion, captured over multiple frames or time-lapse sequences. These are harder to verify because video footage requires knowing the exact observation conditions, timestamps, equipment used, and processing applied. It's much easier to fake or misidentify video content than still images, especially with the proliferation of editing tools and CGI capabilities. Some of these videos claim to show the object maneuvering, changing trajectory, altering velocity in ways inconsistent with passive orbital mechanics. If true, that would be smoking gun evidence of propulsion. If false or misinterpreted, they're noise that muddies the waters and makes serious analysis harder. I haven't seen credible, independently verified video footage showing clear trajectory changes. What I have seen are grainy, low-resolution clips that could be showing a comet or an artifact, or misidentified satellites, or even deliberate hoaxes. Until such footage is corroborated by professional observers with calibrated equipment and published in peer-reviewed analysis, it remains in the interesting but unverified category. The problem with viral enhancements and circulating footage is that they feed two opposing narratives simultaneously. For those inclined toward belief in anomalous phenomena, they're evidence of a cover-up, of amateurs uncovering truths that institutions are hiding. For skeptics, they're examples of how misinformation spreads, how ambiguous data gets overinterpreted, how confirmation bias and poor image processing lead people astray. Both narratives contain elements of truth. There is genuine ambiguity in the October 20th image that invites interpretation. There are also people overinterpreting noise and artifacts as meaningful structure, disentangling signal from noise, real anomaly from processing artifact, is exactly what professional scientific analysis is supposed to do. And that brings us full circle to the frustration that professional analysis has been largely absent from public discourse during this critical period. If NASA or ESA were to release high-resolution imagery from calibrated instruments, processed transparently with methodology disclosed, it would instantly clarify whether structures like disks or sunward jets are real or artifactual. The absence of such data leaves a vacuum, and into that vacuum flow enhanced images, speculative footage, and increasingly sensational interpretations. And here's the uncomfortable possibility. What if the reason professional data hasn't been released is because it confirms, rather than debunks, some of these anomalies? What if high-resolution imagery from Hubble or JWST or solar observatories does show structure that shouldn't be there, and institutions are holding it while they figure out how to explain it or whether to release it at all? That's speculation, but it's speculation grounded in the observable fact that we're not seeing the data we should expect during a high-priority observation event. Either observations weren't made, which is scientifically negligent, or observations were made and are being withheld, which raises entirely different questions. As of October 21st, we're 7 days from perihelion, 7 days from the moment when, if trajectory changes occur, if structural features become clearer, if anything about this object behaves in ways that defy natural explanation, we'll have our answer. And in those 7 days, the enhanced images, the viral videos, the circulating theories are all building anticipation and anxiety, creating an atmosphere where October 29th won't just be another perihelion passage. It'll be an event millions are watching, expecting revelation or vindication or debunking or disaster, transforming an astronomical observation into a cultural moment that could reshape how humanity thinks about whether we're alone, and whether we've just been visited by something that sees us as curiosities, resources, threats, or perhaps nothing at all. Let's talk about the person who's been willing to say out loud what many scientists think privately, but won't voice publicly. Avi Loeb and his 30 to 40% estimate that 3IATLAS might be of artificial origin, because when a Harvard astrophysicist with decades of experience, hundreds of peer-reviewed publications and former leadership positions in major scientific institutions puts those odds on an interstellar object being technology, you have two choices: dismiss him as recklessly speculative, or take seriously the possibility that he's seeing something in the data that demands uncomfortable consideration. Loeb developed what he calls the Loeb scale as a framework for quantifying how anomalous an astronomical object appears, based on deviations from expected natural behavior. It's a semi-formal metric, not yet peer-reviewed or widely adopted, but it provides structure for discussing something science has traditionally avoided: how to assess whether an object might be artificial when our default assumption is always natural origin. The scale runs from 1 to 10, with 1 representing completely ordinary objects that fit all expectations, and 10 representing objects that cannot be explained by any known natural process. Loeb places 3IATLAS at 6 significant anomalies: multiple unexplained features, behavior that stretches conventional models, not definitive proof of artificial origin, but enough accumulated oddities that artificial origin becomes a hypothesis worth serious investigation rather than immediate dismissal. What does a 30 to 40% probability mean in practical terms? It's not a precise statistical calculation. You can't plug the data into Bayes' theorem and get that number out. It's Loeb's subjective assessment, informed by his analysis of the anomalies we've discussed: the composition, the outgassing behavior, the trajectory, the spectroscopic signatures, the photometric properties. He's essentially saying that when he weighs natural explanations against artificial ones, he finds the natural explanations collectively less probable than about 60 to 70%, leaving a 30 to 40% residual probability for artificial origin. That's a shocking number. For context, most scientists would estimate the probability of any given interstellar object being artificial at something like 1 in a million or less. Because we've never confirmed artificial objects from other systems, and the universe appears to produce an enormous abundance of natural interstellar debris through planetary system formation and gravitational ejection. To shift that baseline probability from 1 in a million to 30–40% requires extraordinary data so anomalous that natural explanations start to require more assumptions and special pleading than the hypothesis of artificial origin. Loeb's central argument revolves around the Oumuamua maneuver possibility. If 3IATLAS is an artificial probe, perihelion on October 29th would be the optimal moment to execute a propulsion burn, firing engines deep in the sun's gravity well, when the object is already moving at peak velocity, would maximize delta V for a given fuel expenditure. This is basic orbital mechanics, taught in every astronautics course. Human spacecraft use Oumuamua maneuvers routinely: Voyager missions, New Horizons, every interplanetary probe that performs gravity assists and burns at periapsis. If you were designing an interstellar probe intended to explore a target system, you'd want to maximize observational opportunities while minimizing fuel use. A trajectory that takes you close to the star and major planets, with a perihelion burn to adjust your outbound path or boost velocity for the next phase of exploration, would be textbook mission design. And that's exactly what 3IATLAS's trajectory looks like, whether by intent or coincidence. Loeb has suggested several possible scenarios if 3IATLAS is artificial. 1. It's a passive reconnaissance probe, an automated system sent to gather data on planetary systems, mapping exoplanets and stellar environments without interacting. If so, perihelion might involve course corrections, antenna deployment for data transmission, or activation of systems that have been dormant during interstellar cruise. These activities might produce observable signatures: brief accelerations, deployment of structures, thermal emissions inconsistent with solar heating alone. 2. It's a post-biological probe, an AI-driven system representing a civilization that has moved beyond organic biology. Such a probe might be millions of years old, sent when its origin civilization was still biological, now carrying out programming long after its creators are gone. Its behavior would be determined by mission parameters designed for scenarios its builders anticipated, but which might not perfectly match what it encounters, leading to unexpected responses. 3. And this is where Loeb has been particularly vocal in calling for preparation. It's an active probe capable of communication or interaction. If that's the case, perihelion might trigger attempts at contact, radio transmissions, optical signals, releases of material intended to convey messages. Or In darker scenarios, it might involve defensive or offensive actions if the probe assesses the system as hostile or valuable enough to secure. Loeb has gone so far as to call for United Nations involvement, suggesting that a potential close approach of artificial technology on December 19, 2025, when 3IATLAS makes its nearest pass to Earth at approximately 0.7 AU, he's argued for protocols similar to those discussed for asteroid impact preparedness, coordination between space agencies, military establishments and civilian governments to ensure observation assets are ready, communication channels are open, and response frameworks exist. If something unexpected occurs, that's not alarmism from a fringe figure, that's a respected scientist calling for institutional readiness in the face of non-negligible probability. And the fact that no such preparation has been publicly announced, that there's no visible coordination or heightened alert status, either means institutions are ignoring Loeb's calls as unwarranted, or they're taking them seriously in classified settings we're not privy to. Now, let's be clear about what pushback Loeb has faced. Many of his colleagues in the astronomical community have criticized his public statements about 3IATLAS and his earlier advocacy regarding Oumuamua, the first detected interstellar object, which Loeb also suggested might be artificial based on its acceleration anomaly and unusual shape. Critics argue that Loeb is prematurely leaping to extraordinary conclusions without exhausting natural explanations, that his estimates of artificial probability are unjustifiably high, and that his public speculation risks damaging scientific credibility by feeding conspiracy theories and sensationalist media coverage. Those criticisms aren't baseless. Science operates on the principle of parsimony, preferring natural explanations until evidence compellingly demands otherwise. Jumping to its aliens when we don't fully understand something risks becoming a modern God of the gaps fallacy, attributing to intelligence what we simply haven't figured out yet. And there's legitimate concern that high-profile scientists speculating publicly about alien technology creates noise that makes sober analysis harder, turning scientific investigation into media spectacle. But here's the counter-argument, and it's one Loeb has made repeatedly. If we never allow ourselves to seriously consider artificial origin until we have definitive proof, we'll miss opportunities to gather the data necessary to establish that proof. Science requires hypothesis generation, and if artificial origin is ruled out a priori as too extraordinary to consider, we won't design observations to test it. We won't prioritize high-resolution imaging to look for structures. We won't analyze trajectory deviations for signs of propulsion. We won't monitor for communication signals. We'll keep forcing the data into natural frameworks, adding epicycles to make the models fit, until the evidence becomes so overwhelming that we've wasted precious time we could have spent investigating seriously. Loeb argues we're at the threshold where 3IATLAS's anomalies justify moving artificial origin from fringe speculation to testable hypothesis. And testing it requires resources, observation time, institutional support, things that require convincing scientific and governmental bodies that it's worth the investment. His public statements, his 40% probability estimate, his calls for UN preparation are all attempts to shift institutional inertia, to make the scientific establishment take seriously what the data are suggesting, even if it's deeply uncomfortable. And here's the critical question: what if he's right? Not definitely right, but even partially right, say 20% probability instead of 40, but still far above baseline. What if there's a real significant chance that we're 8 days away from observing the first confirmed artificial object from another stellar system passing through perihelion, potentially executing maneuvers, possibly revealing capabilities that confirm intelligent design? If that's the case, and we're not prepared, not observing with the right instruments, not monitoring for the right signatures, not having frameworks in place to interpret or respond, we'll have failed one of the most consequential moments in human history through sheer institutional inertia and fear of looking foolish. The cost of preparing and being wrong is wasted resources and some embarrassment. The cost of not preparing and being right is incalculable, Loeb frames this as a calculated risk, a gamble where the stakes are asymmetric. If he's wrong about 3IATLAS, the scientific community will say, "We told you so." He'll take reputational damage, and life moves on. If he's right, and institutions ignored the warnings, the damage is civilizational, not because an alien probe will harm us, but because we'll have missed the opportunity to engage properly with the most significant discovery imaginable, potentially mishandling first contact, or failing to gather critical data that could advance science by centuries. And so, as October 29th approaches, we have this strange situation. A prominent scientist publicly stating, there's a 30–40% chance an incoming object is technology, urging observation and preparation, while institutions remain publicly silent. Amateur astronomers are capturing the most visible evidence, and the broader public is caught between dismissing it as conspiracy fodder or wondering if something genuinely historic is about to unfold. Loeb's gamble is not just a scientific bet, it's a moral and practical one. He's betting that transparency and preparedness are worth the risk of being wrong, that speaking uncomfortable truths publicly is better than cautious silence, and that the scientific method requires actually testing extraordinary hypotheses rather than rejecting them out of hand. And in 7 days, on October 29th, we'll begin to see whether that gamble pays off or whether it becomes a cautionary tale about the dangers of letting imagination outrun evidence, shaping the narrative that leads us into the revelations or disappointments waiting just beyond the sun's glare. Now we need to talk about the things circulating in the darker corners of the internet, the claims that are hard to verify, the rumors that sound like science fiction, the alleged observations that, if true, would be staggering, but which remain frustratingly unconfirmed by independent, credible sources. Because part of analyzing 3IATLAS honestly requires distinguishing between what we can document and what might be disinformation, misinterpretation, or genuine signal being dismissed too quickly. Let's start with the Fibonacci sequence claims. On or around October 13th, 2025, a researcher named David Sereda, known in some circles for work on unconventional propulsion and signal analysis, allegedly reported detecting radio emissions from the direction of 3IATLAS that followed the Fibonacci sequence. For those unfamiliar, the Fibonacci sequence is a mathematical pattern where each number is the sum of the previous two, 1, 1, 2, 3, 5, 8, 13, 21, and so on. This sequence appears frequently in nature, in the spiral arrangements of sunflower seeds, the branching of trees, the proportions of nautilus shells. But it's also been proposed as a potential universal mathematical language, something an intelligent civilization might use in a signal to demonstrate intentionality and non-randomness. If 3IATLAS were emitting radio pulses following the Fibonacci sequence, that would be difficult to attribute to natural processes. Natural radio emissions from astronomical sources tend to be either random noise or periodic signals driven by rotation or orbital mechanics, not complex mathematical patterns. A Fibonacci sequence signal would strongly suggest intentional design, an attempt at communication using a mathematical structure likely to be recognized by any sufficiently advanced technological civilization. But here's the problem. I cannot find independent confirmation of Sereda's claim. No major radio telescope facility, Arecibo is defunct, but we have the Very Large Array, Green Bank Observatory, Parker's Observatory, has published data corroborating these signals. If Fibonacci pulses were being detected, they would be trivial to verify with independent observations. Radio astronomy is a mature field with global networks of telescopes. The absence of confirmation raises serious doubts. It's possible Sereda detected something real but misinterpreted it. Radio interference from terrestrial sources, a satellite transmission, background noise that coincidentally resembled a pattern. It's also possible the claim is exaggerated or fabricated, either for attention or to seed disinformation. Or, in the least likely but most concerning scenario, the signals were real, detected by others as well, and are being suppressed or ignored by institutions unprepared to deal with the implications. Without seeing the raw data, the analysis methodology and independent replication, the Fibonacci pulse claim remains in the unverified column. It's provocative. It fits the narrative of artificial origin, but it's not something we can rely on as evidence. Next, the alleged observatory shutdowns. As mentioned earlier, claims circulated that certain observatories, particularly NASA's Solar Dynamics Observatory, stopped publicly updating imagery around October 13th, the same date as the alleged Fibonacci signal detection. Coincidence? Coordination? Or simply a misreading of normal data release schedules? I want to be extremely careful here, because I haven't personally verified whether SDO's data stream was actually interrupted. Public data archives can have delays, maintenance windows, gaps due to technical issues. Solar observatories occasionally go offline for calibration, software updates, or to avoid observing during solar events that could damage instruments. It's entirely plausible that any perceived gap around October 13th was routine and unrelated to 3IATLAS. But the perception of coordinated shutdown, multiple observatories going dark around the same time, has fed speculation that something was detected which prompted a decision to restrict public data access. If observatories did shut down or restrict data, and if that coincided with the Fibonacci signal timing, it would suggest either extraordinary coordination to suppress information or a massive coincidence. The burden of proof for such claims is high. Extraordinary claims, cover-ups involving multiple institutions across multiple countries, require extraordinary evidence. Vague reports of observatories went offline without specific names, dates, confirmation, or plausible mechanisms for coordinated suppression aren't sufficient. They're conspiracy seeds that grow in the absence of transparent data but wither under scrutiny. Then there are the visions and predictions, which venture into territory that most scientists would immediately dismiss, but which have gathered attention in certain communities. A pastor named Paul Biggs, associated with some Christian eschatological groups, allegedly had visions in 2024 or early 2025, predicting an October event tied to interstellar phenomena and potential extraterrestrial contact. The details are vague and subject to interpretation, but adherents point to the timing, October 2025, around the perihelion of 3IATLAS, as potential validation of prophetic insight. I'll state clearly, visions and prophecies are not scientific data. They're subjective experiences, often culturally and religiously framed, that can appear to align with events only in hindsight through selective interpretation and confirmation bias. Humans are extraordinarily good at finding patterns and connections where none exist, especially when motivated by belief systems or desire for significance. That said, it's worth noting that the convergence of multiple narratives, scientific anomalies, conspiracy theories, religious predictions around October 2025 and 3IATLAS is itself a social phenomenon. If nothing happens, these narratives will fade, remembered as another instance of millennial anxiety and misplaced pattern recognition. If something does happen, they'll be cited as evidence of foreknowledge, and the question of how predictive insight could occur becomes its own mystery. There's also the timing coincidence that some have noted. October 29, 2025, is close to several historically significant dates in religious and UFO lore. The anniversary of the Fatima apparitions, the Orson Welles War of the Worlds broadcast anniversary, various UFO sighting anniversaries. Are these meaningful? Almost certainly not. Humans mark time with events, and if you look at any date, you'll find historical coincidences that can be spun into narratives. Pareidolia applies to time as much as to patterns in images. But the fact that these coincidences are being noted and circulated tells us something about the atmosphere surrounding 3IATLAS. This object has become a canvas onto which people project hopes, fears, and narratives, scientific, conspiratorial, religious. It's a Rorschach test for humanity's relationship with the unknown, and our readiness to confront the possibility that we're not alone. Now let's talk about the most testable of these rumors, predictions that something will happen on specific dates. If David Sereda or others claimed Fibonacci signals on October 13th, we can look for subsequent observations. If predictions said observatories would shut down, we can check public data archives for gaps. If religious visions claim an October event, we have October 29th perihelion and the weeks following to see if anything manifests. This is where speculation either gets validated or discredited. And critically, this is where the scientific process excels: testable predictions, observable outcomes, evidence that can be checked. If perihelion on October 29th passes with 3IATLAS behaving exactly as a comet should, with no trajectory changes, no signals, no structural revelations, then the accumulated speculation collapses. The anomalies will be explained as mundane misinterpretations, and the rumors as noise. If, however, October 29th brings observations that cannot be easily explained, a trajectory change, a signal detection confirmed by multiple independent observatories, visual evidence of structure or deployment, spectroscopic signatures of non-natural materials, then the rumors gain retroactive credibility, and the question of how much was known when and by whom becomes urgent. As of October 21st, we're in the window where rumor and reality start to converge or diverge, 8 days until perihelion. Then post-perihelion observations as the object emerges from solar conjunction. Then the December 19th Earth close approach. These are the dates where predictions will be tested and narratives will either solidify or dissolve, and in that testing we have to be honest about our biases. Those who desperately want 3IATLAS to be artificial will seize on any ambiguous data as confirmation. Those who desperately want it to be natural will dismiss even clear anomalies as artifacts or misinterpretation. The truth requires holding both possibilities simultaneously, following evidence wherever it leads, and being willing to change conclusions as data accumulates. The Fibonacci signals, the observatory shutdowns, the visions, their noise until proven signal. But in the presence of confirmed anomalies like unusual composition, strange outgassing, and amateur images showing inexplicable features, even noise starts to sound like something that might, just possibly, be trying to tell us something we're not ready to hear, pushing us toward a reckoning that's either just days away or forever postponed by the ordinary passage of yet another cosmic visitor through our system. Now we have to consider the scenarios that no one wants to think about, but that responsible analysis demands we at least examine. If 3IATLAS is artificial, if the anomalies and observations we've discussed are evidence of technology rather than exotic natural processes, then we have to ask what kind of technology built for what purpose, and what are the implications for humanity. Let's start with the least threatening possibility: a passive reconnaissance probe. Imagine a civilization millions of years ahead of us, technologically capable of interstellar travel and long-duration autonomous missions. They build probes, thousands or millions of them, and send them out into the galaxy with instructions to visit star systems, gather data on planetary environments, stellar characteristics, and any signs of life or technology, and either transmit that data home or store it for eventual retrieval. Such a probe would be optimized for longevity, efficiency, and stealth. It wouldn't announce itself or attempt contact, unless programmed to do so under specific conditions. It would gather data passively, using sensors that observe electromagnetic emissions, chemical signatures, gravitational fields. It might pass through a system multiple times over millennia, updating records, tracking planetary evolution, noting the emergence or extinction of technological civilizations. From our perspective, such a probe would appear as an interstellar object with unusual properties: low outgassing because it's not a comet, trajectory optimized for observation because it's maneuvering, compositional oddities because it's constructed rather than accreted. It would be essentially harmless, interested in us, the way biologists are interested in an ant colony, observing, cataloguing, but not interacting. If 3IATLAS is this kind of probe, then perihelion on October 29th might involve course corrections, data transmission, or system activations that have observable signatures, but it wouldn't mean threat. It would mean we've been noticed, which is its own kind of profound realization, but not an immediate danger. Next scenario: a post-biological probe representing a civilization that has transcended organic existence. Many futurists and scientists speculate that any civilization that survives long enough to achieve interstellar travel will likely transition from biological to digital or cybernetic forms. Biological life is fragile, short-lived, constrained by environmental needs. Machine intelligence, by contrast, can endure for millions of years, doesn't require atmosphere or water or warmth, can be backed up and replicated, can survive the long darkness of interstellar travel without the need for life support. A post-biological civilization might send probes that are essentially the civilization itself, AI entities with decision-making capabilities, curiosity, possibly consciousness in forms we wouldn't recognize. These probes would be explorers in the truest sense, not just sensors gathering data for distant creators, but entities experiencing and interpreting the galaxy firsthand. Such a probe encountering our solar system might have complex motivations. It might seek knowledge for its own sake, attempting communication to learn about human consciousness and culture. It might have ethical programming that directs it to avoid harming emerging civilizations. Or it might have no concept of ethics we'd recognize, operating on decision frameworks so alien that its intentions are fundamentally opaque to us. The challenge with a post-biological probe is unpredictability. We can't assume it will behave benevolently or hostilely. We can't even assume those categories apply to its thought processes. It's a fundamentally alien intelligence, shaped by millions of years of evolution in an environment and substrate completely unlike ours, and our attempts to model its behavior might be as futile as an ant, trying to understand human geopolitics. Now we get into darker territory, the von Neumann probe, specifically the Berserker variant. John von Neumann theorized self-replicating machines that could explore the galaxy by traveling to star systems, using local resources to build copies of themselves, and sending those copies onward, achieving exponential exploration coverage. A benign von Neumann probe is a scientific tool, a malicious one, a Berserker, named after the Fred Saberhagen science fiction series, is an extinction weapon. Imagine a civilization that decides for whatever reason to prevent any other technological civilizations from arising. Maybe they're paranoid about future competitors. Maybe they've had bad encounters with other species. Maybe it's a game-theoretic move driven by dark forest logic. The idea that in a galaxy where resources are finite and intentions unknowable, the safest strategy is to eliminate any potential threats before they become threats. Such a civilization could build self-replicating probes programmed to identify emerging technological civilizations and destroy them. These probes would travel the galaxy for millions of years, reproducing at each stop, creating a wave of sterilization that sweeps through the Milky Way. Any star system showing signs of technological activity, radio emissions, atmospheric pollution, evidence of spaceflight would be targeted. If 3IATLAS was such a probe, its behavior would make sense. It would approach the inner solar system to assess our technological level. It would observe our communications, our satellites, our planetary modifications. Once it confirmed we're a technological species, it would execute whatever elimination protocol it's programmed with: kinetic impactors, biological agents, electromagnetic pulsars, or something we can't conceive of. The perihelion on October 29th could be positioning for an attack, using the Oberth maneuver to accelerate fragments or weapons toward Earth, timed to arrive weeks or months later when our guard is down. Or it could trigger replication using solar resources to build copies of itself that disperse throughout the system, ensuring our planet can't escape observation or eventual action. This is the nightmare scenario. And before you dismiss it as science fiction paranoia, consider we don't know how common intelligent life is. We don't know whether the galaxy has been sterilized by ancient conflicts or by automated systems designed for just such sterilization. The Fermi paradox, the question of why we haven't detected any signs of alien civilizations despite the galaxy's age and size, has many proposed solutions, and one of them is the Great Filter, the idea that something prevents civilizations from reaching interstellar prominence. If the Great Filter is ahead of us, rather than behind us in our evolutionary past, then encountering an interstellar probe might be the moment we discover what that filter is. Now let's balance this with rationality. The probability that 3IATLAS is an extinction weapon is extremely low. We've observed two confirmed interstellar objects, Oumuamua and 2I/Borisov. Before this one, neither showed any signs of threat. If the galaxy was saturated with berserker probes, we'd expect frequent encounters, not rare events, and there's no evidence, none that 3IATLAS has hostile intent. All we have are anomalies that could be explained naturally, or as benign technology, but low probability is not zero probability, and when the stakes involve potential extinction, even tiny probabilities deserve consideration. This is why Avi Loeb and others have called for preparedness, not panic, not militarization of space, but simply having observation protocols, communication frameworks, and response plans ready in case, however unlikely, something unexpected occurs. There's one more scenario worth mentioning, and it's philosophically the most challenging. What if 3IATLAS is a message, but not in the form we expect? Not a radio signal or visual display, but the object itself as an information carrier, its structure, trajectory, and composition encoding data, meant to be interpreted by any sufficiently advanced civilization that observes it closely. This concept, sometimes called a Bracewell probe after the scientist who proposed it, suggests that interstellar communication might not rely on transmitting signals across light years, hoping someone receives them. Instead, you send physical probes that wait in or near target systems, observing until technological activity indicates a civilization capable of recognizing the probe as artificial, then revealing themselves or their message through behavior or structure. If 3IATLAS is such a probe, then the anomalies, the unusual composition, the trajectory, the perihelion timing might be intentional. They're designed to be noticed, to be ambiguous enough that natural explanations seem strained to provoke investigation and close study. The probe is a puzzle, and solving the puzzle reveals the message. What would that message be? A greeting? A warning? An invitation? A test of our observational and analytical capabilities? We won't know until we've examined every detail, tracked every behavior, and decoded whatever information might be embedded in the object's physical properties. These scenarios, reconnaissance, post-biological explorer, berserker, information carrier, span a vast range of possibilities, from benign to catastrophic, and the uncomfortable truth is that we can't narrow them down based on current data. The anomalies we've observed are consistent with several of these explanations, but definitive for none. What we can do is recognize that if any of these possibilities are real, October 29th matters enormously. It's the closest approach to the Sun, the optimal moment for any propulsion or deployment, the point at which passive observation transitions to potential action. If 3IATLAS is going to do something, transmit, maneuver, fragment, deploy, perihelion is when we're most likely to see it. And then there's December 19th, 2025, the closest approach to Earth at approximately 0.7 astronomical units, roughly 105 million kilometers. For a passive probe, that's an ideal observation distance. For a communication attempt, it's close enough that signal travel time is short. For a threat, it's worryingly near, though still far enough that any projectile would take weeks or months to reach us, giving time for detection and potentially response. These dates are inflection points, moments when speculation becomes testable, when possibilities narrow or expand based on what we observe. And as we count down the days, the challenge is holding uncertainty without collapsing into either blind dismissal or unchecked fear, recognizing that the truth could lie anywhere along the spectrum from perfectly ordinary comet to the most significant event in human history, with everything riding on observations we're about to make or fail to make in the coming week. October 21st, 2025, 7 days remain until 3IATLAS reaches perihelion, and the waiting is almost over. 7 days until we see whether this object behaves as comets should or reveals something we've never witnessed before. And then, regardless of what happens at perihelion, we have a roadmap of observations stretching into 2026 that will either put this mystery to rest or deepen it beyond anything we're prepared to handle. Let's talk about what we should expect if 3IATLAS is an ordinary comet behaving unusually. Perihelion on October 29th will subject it to the most intense solar heating of its entire trajectory through our system. At closest approach, temperatures on the sunward surface will reach extremes capable of vaporizing not just water ice, but even more refractory materials like silicates and metals if exposed long enough. Any remaining volatiles, water, carbon dioxide, methane, ammonia, should undergo explosive sublimation, producing a massive coma and tail visible from Earth even through solar glare. If the object survives perihelion intact, we should see a dramatic increase in brightness and outgassing. Comets that pass very close to the Sun often fragment due to thermal stress and tidal forces, breaking into multiple pieces that slowly separate over subsequent weeks. If 3IATLAS fragments, that would actually support natural comet classification. It would indicate a loosely bound icy body that couldn't withstand close solar passage. Fragmentation would be, ironically, a reassuring outcome. But if the object remains intact, with no fragmentation, low outgassing, and a trajectory that precisely follows gravitational predictions with no deviations, then we have to ask why. What kind of comet survives that close to the Sun without falling apart or producing significant coma? It would have to be either exceptionally dense and structurally coherent, more like a solid rock than a rubble pile, or have some kind of protection against thermal stress that natural materials typically don't provide. Now, let's outline the observation opportunities coming up, because this isn't just about October 29th. We have a sequence of critical dates where high-quality data should become available if institutions are doing their jobs. November 4th, 2025, ESA's JUICE spacecraft, currently in transit toward Jupiter, has an observation window for 3IATLAS. JUICE carries high-resolution cameras and spectrometers designed for planetary science. While it's not optimally positioned, JUICE's trajectory is taking it outward from the Sun, and 3IATLAS will be post-perihelion. There's a geometry window where JUICE could capture images from a perspective unavailable from Earth. If JUICE observes and releases data, we'll have spacecraft-quality imaging to compare against amateur photographs like Dobsonian Power's October 20th image. Discrepancies or confirmations will be telling. December 19th, 2025. Closest approach to Earth at approximately 0.7 AU. At this distance, Earth-based telescopes will have optimal viewing conditions, free from solar glare, with the object well placed in the sky for Northern Hemisphere observers. Professional observatories will have no excuse not to observe. We should expect high-resolution imaging, spectroscopy, radar observations, if the object is within range, and detailed trajectory measurements. This is also the date Avi Loeb has flagged as significant for potential communication or interaction if 3IATLAS is artificial. A probe designed to observe or contact Earth would logically do so during close approach when signal travel time is minimized and Earth is most visible. If there's going to be a signal, radio, optical, or otherwise, December 19th is a prime window. March 16th, 2026. NASA's Juno spacecraft, in orbit around Jupiter, has a scheduled opportunity to observe 3IATLAS as it passes through Jovian space. Juno's instruments are designed for Jupiter's magnetosphere and atmospheric analysis, but they can be repurposed for comet observation if mission planners prioritize it. A Juno flyby would provide close-range data impossible to get from Earth, potentially resolving details of the nucleus, detecting any internal structure, and measuring properties like density and magnetic field if present. If Juno's observations show a solid, dense object with no signs of volatile loss, especially after surviving close solar passage, that would be extremely unusual for a comet. Conversely, if Juno sees a fragmented, outgassing mess that supports natural origin, Beyond 2026, 3IATLAS will continue outbound on its hyperbolic trajectory, eventually leaving the solar system altogether. Unless we send a dedicated mission, a spacecraft specifically tasked with intercepting and studying it up close, our observation window is limited to the next year or so, while it's still within reasonable range of our instruments. Now, what are we looking for in these observations? Several key signatures would shift probability toward artificial origin. Trajectory deviations. If 3IATLAS's path changes in ways not explained by solar gravity, planetary perturbations, or outgassing forces, that indicates propulsion, even small, precise adjustments. A few meters per second delta V would be detectable with careful astrometry and would be inconsistent with passive dynamics. The Oumuamua maneuver at perihelion is the prime moment to watch for this. If post-perihelion tracking shows the object's velocity or direction has changed beyond natural prediction, we have a major anomaly. Structural features, high-resolution imaging revealing geometric regularity, surfaces with artificial smoothness or patterns, deployed structures like antennas or radiators, anything that looks designed rather than accreted. These would be smoking guns. The enhanced amateur images suggesting disk shapes need professional verification. If JUICE, Juno, or Earth-based telescopes confirm those shapes, the natural explanation space collapses dramatically. Spectroscopic anomalies, detection of materials that don't occur naturally, refined metals, synthetic compounds, isotopic ratios inconsistent with natural nucleosynthesis would be definitive. The nickel without iron observation from Keck needs follow-up. If subsequent spectra confirm unusual elemental distributions or detect anything like industrial alloys or semiconductors, we're no longer talking about a comet. Electromagnetic emissions. Any radio, optical, or other electromagnetic signals coming from 3IATLAS that show modulation, structure, or information content would immediately indicate technology. Natural astronomical sources emit radiation, but it's either thermal blackbody emission or chaotic magnetic processes. A signal with periodicity, encoding, or directional beaming toward Earth would be unambiguous. Thermal signatures inconsistent with solar heating. If 3IATLAS shows hotspots, heat emissions from shadowed regions, or temperature distributions that don't match passive solar heating models, that suggests internal heat generation, power systems, active thermal management, something producing energy beyond what solar input provides. These are testable, observable signatures. They don't require speculation. They're straightforward data points that professional astronomers know how to measure and interpret. The question is whether institutions will prioritize these observations critically, whether they'll release the data publicly in a timely manner. And this is where trust becomes central to the narrative. If October 29th passes, and we see no professional data, if December 19th comes and goes with institutions claiming they observed nothing unusual but releasing no images or spectra, if Juno's 2026 flyby results in vague statements about unremarkable cometary body without detailed data publication, then the silence itself becomes the story. It becomes evidence not of nothing happening, but of something being hidden. Alternatively, if data floods out, high-resolution images showing a fragmented outgassing comet, spectra confirming standard cometary composition, trajectory tracking showing perfect gravitational prediction, then the mystery dissolves. The anomalies are explained as observational errors, misinterpretations, and overeager speculation. Science moves on. 3IATLAS becomes a footnote, and we return to waiting for the next interstellar visitor, hopefully with better instrumentation and less ambiguity. But there's a third possibility, the one that keeps astronomers and defense planners awake at night, data that confirms the anomalies, that shows something genuinely unprecedented, that forces the conclusion we've been dancing around. If that happens, if the observations over the next weeks and months reveal that 3IATLAS is artificial, then October 29th, 2025 will be remembered as the date humanity's cosmic solitude ended. not with a radio message or a visitation, but with the passage of an object through our solar system that we finally, belatedly, recognized as a visitor of a different kind. And in that moment, every question we've been asking about composition, trajectory, intent becomes secondary to the overwhelming realization that we're not alone, that intelligence exists beyond Earth, that the galaxy is or was populated by civilizations capable of reaching across the stars, and that we've just had our first confirmed encounter with their technology. What comes after that recognition is unknowable. Do we attempt communication? Do we mobilize observation and defense assets? Do we wait to see if 3IATLAS does something or simply continues on its journey indifferent to our existence? Do governments disclose what they know, or do they classify everything and control the narrative? These questions can't be answered in advance. They depend on what the data show, how institutions respond, and how humanity collectively processes the end of one era, the era of cosmic loneliness, and the beginning of another, where the universe is no longer an empty stage but a populated landscape, and where the appearance of an interstellar object in our skies is not just an astronomical curiosity, but a message that we've been seen, studied, perhaps judged by intelligences that preceded us into the cosmos, by timescales we can barely comprehend. Right now, on October 21st, 2025, we stand on the threshold. 7 days until perihelion, 59 days until Earth close approach, less than 5 months until the Juno flyby. The countdown has begun, and the truth, whatever it is approaching as inexorably as 3IATLAS itself, hurtling toward the sun at 80 kilometers per second, carrying with it the answers to questions humanity has asked for millennia, or perhaps simply the next layer of mystery in an unfolding encounter that will define our species' place in a universe far stranger, far more populated, and far less indifferent to us than we ever imagined. If you're as captivated by this unfolding mystery as I am, I need you to do something. Share this. Talk about it. Spread it to anyone who cares about what's happening in our skies right now. Because the silence from institutions means the public conversation is the only place where pressure for transparency can build. Like this video, subscribe to the channel, and drop a comment telling me where you're watching from and what you think is really going on with 3IATLAS. Are we witnessing the most significant event in human history, or the most elaborate case of cosmic misinterpretation? We'll know soon. And I'll be here, tracking every development, because this story is far from over. It's just beginning.